Chapter 6. In this chapter, we're going to start discussing some more real life situations like borrowing money and how banks charge interest, how to make house payments, how to pay off credit cards, just a lot of real life situations. Now, in section 6.1, we're going to begin with the topic of being charged interest. So, interest is any amount that is charged to you from the lender, so whoever lends you the money, whether that's a friend or a bank or a car dealership, to you. So, it's the amount charged by a lender for borrowing their money. Principal, that is a very key word, and you're going to see this in a lot of our formulas that we have in Chapter 6. But principal is the amount of money which you're borrowing. So this is how much money you are borrowing and what they're charging you the interest on. So the amount of money on which your interest is charged. Now your interest rate. Your interest rate is always a percentage of the principal. So you're always going to be charged like maybe 12% or 0.7%. You always want to find banks and lenders with the lowest interest rate possible because that's less money that you're being charged to borrow their money. And usually you will see the words annual percentage rate or APR. That is just your basic interest rate for borrowing the money. But a lot of banks and loan companies like to use that terminology. And the main thing to remember is when we're trying to figure out our calculations, anytime you've been given a percentage or a rate, you must convert that rate to a decimal before you begin any of your computations. For example, if you have 83%, remember that the word percent means per hundred, and we move the decimal point 2 times to the left, giving us a decimal of 0.83. Likewise, if I had 7%, my decimal is still here at the back, and when I move that twice, I get 0.07. So always remember your percentages have to be converted to decimals in order to do your computations. Now, the first kind or the first formula we are going to be introduced to is what we call simple interest. And simple interest has a very simple formula. Interest equals your principal times your rate times your time. So in this formula, you want to make sure you highlight that so you can reference it later when you need to. The P stands for principal, or the amount of money that you are borrowing. Your R is your rate, which is going to be a percentage, and you turn it into a decimal. And T represents time. Now, it's important right here to note that your time must always be expressed in years. So if they don't give it to you in years, you're going to have to convert it to years because that is the way the formula works. So we'll start very simple and then we'll get a little more complicated where what do you do if time is not expressed in years? So let's look at the first one. Determine the simple interest. So you want to look for your keyword that you're finding simple interest, and then they're going to give me all of the information I need. Earned on $3,500, so that's my principal. After 4 years, that is in years, so that is my time. If the annual percentage rate is 21.9%, so there's my rate. So to find my interest, I'm just going to reiterate our formula. It's principal times rate times time. So I have 3,500 times my rate. I have to move that decimal point 2 times to the left to give me a decimal of 0.219 or 0.219 times my time in years, which is 4. Now, we are going to be using a calculator a lot in this particular chapter. So if you pull up your basic calculator from your computer, beside of the word standard, go to your little bars, and you want to change this to be a scientific calculator. Now, for what we're doing in this section, it doesn't have to be scientific, but if you go ahead and make it a scientific calculator now, that will help you for the rest of chapter 6 when our formulas get a little more complicated. And we're just going to type this straight into the calculator. 3,500 times 0.219 times 4 years. And when we hit equals, we see that the interest on this loan would be $3,066. And I'll bring the calculator back up so you can see that again. 3,066. Let's look at a second one. All right, again, we're going to start off simple. Determine the simple interest on a $13,500 loan for 6 years, and we have our rate of 3.75%. Now I'm going to go ahead and move that decimal 2 times to the left to give me 0.0375. I also have it in years, so I don't have to worry about any kind of conversion. So our simple interest is principal times rate times time. So our principal is 13,500 times our rate is 0.0375 times our time is 6 years. So again, we'll pull up our calculator, make sure you clear out anything that was in there, and we have 13,500 times 0.0375 times 6. And make sure you hit equals. And you can see that the interest on this problem would be $3,037.50. Now I want to make a point to let you know right here. So when you take out a loan, and many of you already know this, when you take out a loan, you borrow against your money. So we're borrowing $13,500. But the bank is going to charge me an interest rate in order for me to borrow that money. So when I finish my loan off, I am going to have paid $3,037.50 in interest. So that's in addition to the money I'm paying back. So in all, if I were to figure out the total payback, I would have to add my original loan of $13,500 because I have to pay that back. Plus, I have to pay back this much in interest because that's what the bank or the lender is charging me for borrowing their money. Let's look at another one. Now we're getting to a couple of problems where I'm not going to be given the time in years. So how do we convert that? All right, so I'm still finding simple interest. I am borrowing $12,500 at a rate of 6.38%, and I'm only going to borrow that for 180 days, so not even an entire year. So the first thing I'm going to do is change my percentage to a decimal. If I move that decimal point 2 places to the left, it gives me 0.0638. I also need to notice that this is in days. Now, I want to caution you here for days. Typically, there are, if I ask the class how many days are in a year, most people would say 365. That is usually what most banks and most lenders will use is 365 days in a year. And that's what we're going to use in this conversion. But I do want you to know that there are Some textbooks that you see, and even in your software in Hawks, they might say use 360 days instead of 365 to do your computations. So make sure you're paying attention to those directions as to how many days they want you to use in a year in order to do your conversion. So for this one, we are going to say that the directions say that there are 365 days in a year. If it's not expressed to you, then you're going to use 365. So now let's use our formula. Interest is principal times rate times time. So my principal is 12,500 times my rate is my percentage, 0.0638, times my time is now going to become a fraction since it's not given to me in years. I'm going to have my 180 days divided by 365 days in a year. So when you are not given your time in years, you will create a little fraction or a little division problem right here in your computations. So let's pull up the calculator. Make sure you clear out what was previously in there. Right? 12,500 times 0.0638 times, now the fraction, you just do the numerator of 180 divided by 365. And then we're going to hit equals. And we're going to see we get a pretty long answer here. And because we're dealing with money, we're always going to round to 2 decimal places. So when I do this, I'm going to get $393. And if I round, 7 tells 8 to bump up and become 29 cents. So $393.29 rounded. All right, let's look at another. This one, we're going to borrow money for 3 months. Okay, so that's the one I'm looking at. 3 months. How many months are in a year? There are 12 months in a year, and that will never change. So I am going to create a little fraction with that with my 3 over 12. I'm going to go ahead and move my decimal point 2 times for my rate, so that gives me 0.125. And now I'm ready for my formula. Principal times rate times time. So I'm borrowing $2,340 times my rate, 0.125, times my time. I have 3 months out of 12 months in a year. We're going to use our calculator and type that straight in. 2,340 times 0.125 times 3 divided by 12 equals. So I'm only going to pay $73 and round appropriate here, 13 cents. $73.13 in interest. We have another one. Now this one's a little wordier. You can see already it's a little longer. So an online lending company is offering simple interest loans based on credit scores. With our credit score, we can borrow $3,900 for 32 years. That's a long time to borrow money at an interest rate of 11.45%. How much money will you pay the lending company at the end of 32 years? So notice they did not ask me what is the interest. They said how much money am I paying back at the end. So what we have to do is find our interest rate first, or find our interest that we're being charged and add it to how much money we borrowed. So this will be a double step problem. So let's find our interest first. So we have principal times rate times time. Our principal, we're borrowing $3,900. Our rate is at 11.45%. So when you move that decimal, you get 0.1145. And I'm going to put my 0 in front. Times my time, which is 32 years. So we will use our calculator. 3,900 times 0.1145 times 32 years. So I'm going to end up paying $14,000 in interest on a $3,000 loan. Now that looks like it's completely unreasonable, but it's not. I borrowed that money for 32 years. So for 32 years, I have to pay interest back on this money. That is not a typical loan that you would get, especially for a small amount like 3,900. But I just wanted you to know that's why that number is so large. So we don't have to do any rounding here. So my interest is $14,289.60. Now let's make a note. This is my interest only. That's not what the question asked. The question said, how much will I pay back at the end of those 32 years? So I originally borrowed $3,900, so I definitely have to pay that back. Plus, I have to pay back all this interest of $14,289.60. So when I add those two together, I'm going to get that I have to pay back $18,189.60. So a quick addition problem, and you can use your calculator. Now that we understand simple interest, we're going to move on to a different kind of interest called compound interest. Now, what's the difference? So simple interest is calculated on your principal, or the original amount of money that you're borrowing. Very simple formula and focused on your principal amount. What compound interest does is it calculates your interest very differently. It takes your principal amount and it accumulates your interest over your previous periods of time. So it's like you're paying interest on top of interest, and it's compounded. So it's more complicated than your simple interest. So let's look at this formula. You can tell that it's a little more complicated or more compound. You see some very familiar little letters here. So P, let's just point out what these mean again. P is your principal, or the amount of money that you are borrowing. R is your rate, where it's your percentage, and you have to change that to a decimal. T is your time. Again, it is expressed in years. And then we have a new letter in here, and that is N. N is your number of compounding intervals. So it represents number of compounding intervals. In other words, how many times are they going to compound your interest, and you pay interest on interest in this year? So let me show you some words that could be used so that you would know your number of compounding intervals. First, we have the word annually. Annually means that you are getting your interest compounded once a year. Semi-annually or biannually means that it is being compounded twice per year. So your N would be 2. Quarterly. Quarterly means it's going to happen 4 times a year. Monthly. Well, if something happens monthly, it is going to happen 12 times throughout the year because there are 12 months in a year. If your bank or lending company compounds weekly, that is going to be 52 because there are 52 weeks in a year. And if they're compounding daily, we're going to go with the 365 unless you were told otherwise. In our software that we'll be using, we'll use 365. Now, I do want to make a note here. This formula that we're giving here, it does not just calculate your interest like our previous formula did. Our previous formula, it only gave us what interest we were being charged. This particular formula, as long as it is, gives you your future amount with your interest in it all together. So it's kind of giving you your total payback. So let me write that down for you. So this formula, okay, it's gives your future amount. In other words, it's giving you the total that you owe back with the interest included. Okay. So before we had to go and add what we borrowed plus our interest. This formula is automatically giving me that payback. So let's look at an example. Lily deposits $12,000 into an account with an annual interest rate of 1.05% compounded monthly. If she leaves the money in the account for 10 years, what will the future value at the end of this time period be? Round to the nearest cent. So this time, I'm actually getting some money back because I'm depositing it into an account that is going to gain interest, almost like a savings account. So let's see what we're going to have here. So I'm going to rewrite the formula since it's at the top of that page so that we can all look at it. It's 1 plus r over n to the nt power. Okay, so let's identify our parts. Principal, so we're going to have $12,000, parentheses, 1 plus. Our rate is 1.05%, and when I change that to a decimal, I get 0.0105 over N is my compounding intervals, and it told me that it is being compounded monthly. So that is 12 months in a year. So it's going to be compounded 12 times. Close the parentheses to the NT power. So again, N is my intervals, which is 12 times T is my time, and it is given to me in years. So 10 years. Now, I'm going to pull up our calculator and we are going to use it to type this in. Okay. So I want to be very careful that I type it in just the way it's written here. So 12,000 parentheses, I do type in the parentheses, 1 plus 0.0105. The fraction bar is division, so divide it by 12. Close the parentheses. And then I have an exponent of 12 times 10. I want to go ahead and do that math so I don't mess anything up when I'm using my calculator. So if you do 12 times 10, that gives you 120. So this is to the 120 power. Now, how do you do a big power like that? On your calculator, you have an X to the Y button. This means you're taking something and you're putting it to a very strange exponent, nothing normal like a squared. So it's some sort of crazy exponent. So I need to put this answer to the 120th power. So I'm going to hit XY 120 and make sure you hit equals. Now you see we get a very long answer here, so we've got to round. So if I deposit $12,000 in that account and I leave it for 10 years and I'm getting this 1.05% interest rate, at the end of 10 years, remember it's giving me my total, at the end of 10 years, I'm going to have $13,327 and, let's round appropriately here, 92 cents. I'm going to write that answer down for you. $13,327.92 is what I will have after 10 years. Okay. And we have 3 or 4 more to do here. Okay, another one. Suppose an investment earns 6.8% compounded continuously. Find the future value of a $6,200 investment after 18 years, and of course, round to the nearest cent. So, some keywords here. The big one is future value. That lets you know that you're doing the more complicated formula and finding all the future stuff. And the other is compounded continuously. That lets us know that we're not doing simple interest, we're doing a more complicated one. So again, I'm going to write down that formula so that we can reference it right here. We have principal times 1 plus r over n to the nt power. Now let's get all of those numbers in here. So our principal is 6,200. Parentheses, 1 plus, our rate is 6.8%, and when I move that decimal point 2 times, I get 0.068, divided by n is compounded continuously, so that means every day, and there are 365 days in a year, to the 365 times our time, which is 18 years, power. Now, what I would do first is go ahead and multiply your 365 times 18. So that way we have that exponent taken care of. So 365 times 18 is 6,570. So I'm going to mark this out and put 6,570. And now we're going to pull up our calculator and we're able to type in this entire problem. Just like it's written, 6,200, parentheses, 1 plus 0.068 divided by 365, close the parentheses. Now we have that crazy power, so I use that XY button, to the 6,570th power. And don't forget to hit equals. And again, you see we get a very long decimal, and because it's money, we're going to round appropriately. So we are going to have a future value after 18 years of $21,082.33. So let's write that down. $21,082.33. Okay, let's look at another one. This time we are depositing $22,600. We're going to earn 11% interest for 35 years. Again, here's some key words. Calculate the future value of the investment if the interest is compounded weekly. So this is letting me know I'm using my more complicated formula. So again, I'm going to put that formula over here to the side. R over N to the NT power. Okay, so our principal is 22,600 parentheses 1 plus. Our rate is 11%, so as a decimal, that's 0.11. Divided by N is how many times I'm being compounded. That's weekly. We discussed previously there are 52 weeks in a year. To the 52 times our time is 35 years. So again, with my calculator, I would want to go ahead and figure out what 52 times 35 is. 52 times 35 is 1,820. So I'm going to mark that out and put 1,820. And then we're going to use our calculator to figure out our future value. 22,600 parentheses 1 plus 0.11 divided by 52, close the parentheses, to the, so we got to use that XY button, 1,820th power. And you can see we're going to have a lot of money. We're going to have $1 million and some at the end of 35 years. So again, we want to round to 2 decimal places, and 4 tells the 2 to stay, so we're going to have 32 cents. So $1,057,733.32. So that's a pretty good deal right there. Okay. Now let's look at 2 more. These 2 questions are going to be worded a little bit differently than our previous ones. We're borrowing $18,000, well, actually, I'm sorry, we're not borrowing. We're putting $18,350 into an account for 8 years, and we're going to earn 8% annual percentage rate. Calculate the interest if it's compounded monthly. Okay, so I know that I'm doing, because it says compounded monthly, I know I'm doing my more complicated formula. This time it didn't ask me what my future value was. It just asked me what my interest was. But the only formula I have is to find the future value. So again, we're going to use that formula. And we'll fill that in. So our principal, we have 18,350. 1 plus. Our rate is 8%, so as a decimal, that's 0.08. Our intervals are being compounded monthly, so there are 12 months in a year. Again, we have 12 months in a year, and we are doing this for 8 years. So again, the first thing I want to do is go ahead and work out that exponent. If you use your calculator, 12 times 8 is 96. So this will be to the 96th power. Now let's pull up our calculator and type that in. 18,350 parentheses 1 plus 0.08 divided by 12, close the parentheses, XY button, 96th power. And we've got to make sure that we round again appropriately here. So if we're looking at our cents, 9 tells 8 to bump up. So we're going to have 59 cents. So $34,726.59. Now, let's make a note that that is our future value. However, the question says calculate the interest. So I just want to know how much interest am I earning in this account? Not what I've deposited, but just the interest. So in this case, because I've already been given my future value and I just want my interest, I get to subtract. So in the future, I'm going to have $34,726.59, but I only deposited $18,350. So when I subtract these two, I get $16,376.59 that I have earned in interest. So that is the answer to my problem, since they only wanted to know the interest. So again, in this chapter, reading those directions is very important. Now let's do one more like that one. And I'm going to keep the formula right here in view so I don't have to rewrite that down again. Okay. So let's see, same kind of question. This one asks you again to just calculate the interest, but we have to do our future value first. So we see we are borrowing $32,100, parentheses, 1 plus. My rate is 12.6, so that's 0.126, divided by. My intervals, I'm compounding quarterly. So quarterly means 4 times a year. To the 4 times a year, and how many years are we doing this? 4 years. So again, I want to take care of that exponent. 4 times 4 is 16. And now we can pull up our calculator. 32,100, parentheses, 1 plus 0.126, divided by 4, close the parentheses, XY button, 16th power. And we get $52,724.53. So $52,724.53. Again, this is my future value. That's how much I will have. But what is my interest? This is where we get to do that subtracting. In the future, I'm going to have that large amount of money, but I only deposited $32,100 in cash. So the remaining $20,624.53 is my interest, which is what they are asking.